Got it. Over. And then it was, added this definition when it, oh, actually, here, there's another place here is to make the definition more accurate, you would add that, oh, yeah, yes, make this. All right, so I got, and so should I say like, oh, yeah, all right, okay, got it done for part A, then.
That's everything for part A. For part B, we're gonna start with the sentence I crossed out.
Got it.
And just make it very clear that it's part B when you're answering for part B. So part B. You want to say that first you want to say a plane. The plane is an example of an undefined term.
Undefined term. Is that example?
Okay. And then you want to say that the rest of this, a plane extends infinitely, not indefinitely, infinitely in all directions. It has no depth. You also want to add somewhere in here that parallel lines are also undefined because they extend infinitely in both directions.
Okay. Okay. Here, there's number 2. So yeah, it's in the chat.
Okay, let me know when you're ready for us to move on to number 2.
Yeah, I'm ready.
What did you just sent me something over in the chat here? Let me take a look here. Oh yeah, I've still got that. I've got the question up. So the feedback is that the feedback's where you got to look. That's where you're gonna kind of better understand what your teacher wants you to do. The feedback for
Yeah.
number 2, I guess part B, is where would you place the compass based on construction? So you have to talk about the fixed end. And I'm not sure what do they refer to as the other end of the compass? The one where you swing the arc. Did they give that a name in your class?
Well, like they talk about it being the compass being fixed at when you're at. I guess like I don't know, like the like 1 second. Let me look at the class. Okay, sorry. I guess like the pencil. And there's no real.
Well,
I don't like.
let's just so that the everything you wrote is fine. What the instructor thing is, you need to add some information about where you place the constructions, where you place the compass on the constructions. Okay, so when you bisect an angle, you place the fixed end where the 2 points come together. So you have to say that.
God.
Let me know when you'd like me to say some more things on this.
So you would fix the compass at the fixed end and swing it. All right. The
Well,
intersection.
you want to say that the fixed end of the compass goes on one side of the segment, and it goes where the 2 angles, the vertex of the 2
So
angles.
would I
That's
say
kind of a
that?
difference.
So would I say that when Maxim is constructing an angle bisector, he would fix the compass to the fixed end and swing an arm, not really swing
And
that, but
it's the fixed end of the compass. You're saying the vertex of the angle. Okay.
not
So, all
that.
right. So Anton places the fixed end of the compass on both endpoints of the segment. Maxim places the
So I
fixed
guess
end of the compass
Max.
only where
places
where the vertex of the angle is.
end of the compass only where the so Anton places the fixed end of the compass on both endpoints of the segment. Maxion places the end of the compass on where the vertex is. All right. Vertex of the angle. All right. Yeah. Similarity.
Okay, let me know when you're ready for more, because there's more things we can say.
Yeah, I think I'm ready.
Okay. The so Anton has to also Anton also places the fixed end of the compass on the other end of the
Just the
segment, while Maxim can place the fixed end at the intersection of the arc and one of the rays. So basically the point is like one they're both ends are used there, whereas here you're going to sort of an arbitrary place.
got it. All right. I have some fixed of fixed and this one. This is the fixed and place it at the intersection of the arc and the race. All right, I got that down. Now, see, we have two different. All right, let's see. Anton places the fixed end of the compass on both endpoints of the segment. Maxium places the end of the compass on where the vertex of the angle is. Anton also places the fixed end of the compass to the other side of the segment. Well,
So
Maxium can place
yeah,
it at the end of the intersection of the arcs.
there's a bit more here that Maxim uses both intersections of the arc and the ray to create the bisector. So that's
Both ends.
where there's an arc that's swung and swung. Actually, you only need one. There's and then you might add in that they both use a straight edge
Oh yeah,
to
that is true. So
create the
both
bisector.
Anton and Max use straight edge. Let's see. Use
Okay, I think that's everything for that. I mean, I really don't think there's more we can say
Yeah.
on that one. Um, but
Okay.
keep the original stuff. Like, don't just add to it at this point.
Um, yeah, so I'm not sure if you can see, but right now I'm just typing new stuff into it because well, I'm still able to keep the old stuff by copying and pasting it, but it does like kind of reset everything sort of. But
Yeah.
I'm able to add back the old stuff by just copying and pasting it from the. I have another tab open with the feedback and everything. So, anyways, the next one is the one with the two differences. So let me
Yeah.
take this.
So we wanna talk about it's a, there was a lot more that was said than was written down. I'm sure that's part of it. So with parallel lines, you're well, let's start with the perpendicular. So the perpendicular is drawn here. All right, let me help out here. So um, a parallel line is drawn by copying an angle, most commonly a right angle, which is the perpendicular to the original line.
Uh,
Okay, so how do we want to reorganize this? So it says for pair lines. All right, so let me
yeah,
keep the
but I think
first one
most
here.
importantly, she was asking like for explanation of why it's different than why like that specific thing was different between perpendicular and parallel lines. That was another thing, yeah. Like
So in
more,
parallel lines, you're copying the angle.
yeah,
For parallel, for the copied angle is away from the um, existing line. So like you're copying, like we talked about two situations here, like you're copying it here versus down here. The copied angle is away from the existing line. And we
yeah.
can add that here. So because I actually like the way you wrote the second one here. So let me just add that here. Uh, and then we can say for number two here, we can say that uh, uh, perpendicular are intersecting while parallel lines do not. The construction of the per perpendicular lines requires a point on the line, while parallel lines require a point not on the line. That should be a little bit better.
Uh, let me just quickly type something lines about let's- see. With parallel lines, you're copying the angle. Parallel lines are drawn by copying an angle less common, which is a perpendicular to the original line. Copied angle is away from the existing line. And the second one would be perpendicular lines are intersecting, whereas parallel lines do not. Construction of perpendicular lines requires a point on the line, while parallel lines require a point on, not. I think that works. All right. All right. Let me zoom out 1 second. I gotta take a. Actually, I think yeah, it's the same question. Number 4 is the next one. The one where I think I had to choose which person's proof was correct for the. I don't think I need to change much about this, but I mean, just word it a little bit better, but I think other than that, last time we did
Didn't you
it,
say though you got full points on that?
yeah,
Okay, I mean, I wouldn't change anything.
yeah. Let me just
There's no reason to.
go back here. Just grab. All right, yeah. Like for example, for number 3, like it's for each question to put like out of 10, even like yeah, they should just put it out of 10. For most something, the first one, yeah, you should put everything out of 10. So the first two I got 5 out of 10, and then that's why you kind of rephrase it a lot. But then number 3 we did a little bit better, 7 out of 10 last time. And then of course then the fourth one is 10 out of 10 last time. So let me take that answer that we gave last time for number 4. All right.
You
Yeah.
need me to pull it? Are you saying you need me to pull it up from last time, what we wrote, or?
No, wait 1 second. I do need to probably rewrite it because it doesn't seem to be the exact same problem somewhere.
I'm gonna snip in what we wrote, or what it
All
was
right.
last time.
I think it was Pearl's proof was incorrect because in statement 2, angle AKL and angle GKB are not adjacent angles. They're vertical angles. I'm just gonna double check that now. Wait, angle whose proof is incorrect? Right. So they're saying AKG and GKB. So of those two. Right. Yeah, that is equal to 180. Yeah, these two are also equal to 180. For this one, wouldn't yeah, all right. Let me look up his name. Yeah, I think it's well, for the one that's incorrect, it'd be Becky's.
If you sent something over, I didn't get it. Most of these are
Oh,
different proofs.
I don't think I sent you the screenshot yet, but yeah, it is a little bit different. Oh, it sort of it kind of uses the same stuff, just a little bit word differently. So let me put this in the chat. Here. So, yep, here it is. All right. This here it's loading and it's taking a bit, but yeah, there we go. Number 4 is in the chat now.
Okay.
Yeah, it's a little bit different.
Yeah, it's quite a bit different, so we don't want to reuse what's there. All right, let's take a look here. To show proof to show that the measures of vertical angles are equal. Who completed the proof correctly? All right, so the fact that they add up to 180 is the definition of supplementary angles, not the angle addition
Yeah,
postulate.
that's why I thought that Becky's is incorrect because supplementary angles means that two angles add up to 180, which is what they're
So
kind of showing there.
so it's essentially the same in terms of like what you would say, well, yeah, Becky's incorrect because it's not angle addition postulate, it's the definition of supplementary angles.
Becky, right back it in the justifications for statement number 2. Becky was incorrect. I Becky was incorrect because that that it was angle addition postulating um, the correct answer is that is the definition of supplementary angles.
So you might want to add in here that the angle
That
addition postulate means that two angles add together to a third angle,
the
but it is the definition
postulate
of supplementary angles
states that two
that
angles must add up to a third angle. Let's see. In the justification for statement number 2, Becky was incorrect because she put that it was angle addition postulate. The postulate that states that two angles must add up to a third angle The correct answer is the definition of supplementary angles. Okay.
But it's a little bit more. It's 180 when they are on a straight line. It's not just that two angles can be 180. They have to add up. They have to be on a straight line.
For the supplementary,
Yes.
which states that two angles to 180 degrees if they're on a straight line, which is 180 degrees. All right. The justification for statement number 2, Becky was incorrect because she put that it was angle addition postulate, the postulate that states that two angles must add up to a third angle. The correct answer is the definition of supplementary angles, which states that two angles add up to 180 degrees if they're on a straight line, which is 180 degrees.
All right. Do you feel good about your resubmission here?
Yeah, let me just look it over once.
Okay.
Let's see, so we got number 1, next the contradicts split up to side because we're on the same plane. Over there on the same plane. Here. To make this definition more accurate, you would add lines supposed to be on the same plane. All right. The plane is an example of an undefined term. The plane extends indefinitely in all directions and has no depth. Parallel lines are also undefined because they extend indefinitely in both directions. All right, number 2, asking. Anton places the fixed end of the compass on both endpoints. But I think she also wants us to say that like he's finding like the width within like the two and remember here let me add that.
Yeah, you're welcome to add to what we've put down. It
Yeah,
sounds like more is better this time than less.
Anton places the fixed end of the compass on both. Getting getting the width from the, how do you say that it's like he's like getting the width from like the width of the compass?
Because
I'm
the
not sure.
measuring the arc is what it's called.
All
The
right,
length. Yeah, measuring the arc is probably good.
measuring the arc. All right, there we go.
Yeah.
Yeah, I was kind of
All
confused
right.
on what you'd call that. All right, yeah,
I think it'll be okay.
yeah.
Don't fret. It's just one part of the course, but we're going to stop right here.